recording and share screen. Hold on. Need to admit and then start to share screen. Share screen. Which one? This one. Okay, so today we will start with new concept. Okay. Before we start a new concept, so how about let's do a quick review. We already discussed OOP. The OOP. 3 features. So who still remember the major 3 features that we discussed so far?
They are encapsulation, inheritance, and polymorphism.
Yeah, very good. Encapsulation, inheritance, and the polymorphism. Very good. And generally speaking, encapsulation, the related keyword in Java we use is what? How do we achieve encapsulation?
Use private keyword.
Yeah, very good. That keyword is private. How about inheritance?
Define a subclass, extend to a superclass to inherit attributes and methods from superclass.
Yeah, very good. Extends, is it? And some related is protected, is it? And how about polymorphism? So what is polymorphism we learned so far? And yeah, go ahead, Tuyen.
We can pass an object of subclass into a method that the parameter is superclass type.
Yeah.
Type,
Yeah.
and the object we pass will use the corresponding method,
Yeah.
like method of itself, not the method of superclass.
Yeah, exactly. Okay, so even though the method you defined, when you define, you use superclass method, is it? And when you plug in, it will automatically, if you plug in with a subclass object, it will automatically switch to call the corresponding subclass's method. Okay, that's a polymorphism. And we also learn dynamic binding. Not binding, binding, okay. Dynamic binding. The dynamic binding is even though you have the variable type as superclass, is it? But if it's associated with subclass instance, is it? And when you call the method, it will use subclass's method. That's called dynamic binding. Is it? Just a quick concept review, okay? And then today we will we will learn new concept, okay? So basically, we cover majority of chapter 11 material, just one left over, I believe is array, but array list, but later on we will learn. And so today we will move to chapter 13, okay? So if you read the textbook, is in chapter 13. And to discuss a new concept about abstract class. And so far, the classes we learned. We learned concrete class. Hold on, I have admit all. So far, you see the classes we learned, we call them concrete class. Is it because we can use them, to create instances? Is it instances? Where do we create instance? In stack memory or in heap memory? Wherever we see we create instance, where do we create instance? Who knows the answer?
Heap memory.
Yeah, heap memory. Okay, very good. Okay, so far the classes we learn concrete classes because we use them to create instances. Okay, so today we are going to learn a new concept called abstract class. Okay, and for abstract class, then it's opposite of concrete class is you cannot, okay, be careful, it's not. You cannot use abstract class to create instance. So it's not allowed, okay. Then let's see, what is that? How do we define it? Is it so? Here, we have the second example. If you check our course website, the name is Chapter 13, Example 2, Employee. That over here, you see, I have a number of Java files that I have employee.java file. Okay, so that's the first Java file we will look at. So in this Java file, what we define a public employee, class employee. So nothing new here, is it? But if you take a close look, you will find before class, there is another keyword called abstract, is it? So with this word, it defines an abstract class. Previously, of the class we learned, we never use this keyword, is it? So defines an abstract class. Okay, so that's about this employee class. And then let's scroll over to see what this class has. And if you take a look, its instance variable as first name, last name, social security number, similar as what we learned in our previous employee example, and the string, so nothing new here. Instance variables. Is it nothing new here? And then we have a constructor. Is it? So this constructor has parameters for first name, last name, and social security. And here we also add a printout. Okay, output said, okay, this going to be called. Okay, and we have a mutator. Is it set first name, accessor get first name. So nothing new here, okay. Set the mutator for the instance variable first name, etc. And get the accessor for instance variable first name, nothing new. And then same thing for the last name. The last name, we have set last name, okay, for instance variable last name. And we have get last name for instance variable get last name. And set security, get social security number. Of this, nothing new, etc. And the toString method override, etc. And we call, you can call get first, get last, and get social security, etc. Okay, just another review, okay. This toString here, it's override. Override, when do we use override? So when do we use override? Can I just add here, get Social Security override? Just try to reinforce the concept. Is this correct? The get Social Security number, I add the override.
No.
No, yeah, very good. No, is it? So that's wrong. Okay, you cannot do that. But here, toString, I can do that. Why? Why I can do to override at this annotation?
Because superclass object has toString method.
Yeah, because the superclass object that it has that toString. And here I don't want to use objects toString. I want to have the first and last name Social Security output. Is it? Object doesn't have Social Security number, first name, last name. Is it? So over here, you need to override that toString method. So you put the annotation override, okay? Okay, nothing new here so far, but let's see this last method. Anything strange for this method? Any strange thing for this method you notice? You observed?
It doesn't have curly braces and it doesn't have return method.
Yeah, so it doesn't have, what do we call the curly brackets? What do we call that?
Parameters?
No, what I mean is this.
Statement?
Yeah, and generally we don't see, we call that, okay, their official name, just keep that in mind, okay? It's called the method body. Okay, generally speaking, this is called function prototype. So method prototype. So prototype is no implementation, is it? So method body or implementation. So just keep those professional word in mind, okay? So like this method, is it this part of this part? We call it method header. Header, is it? So a complete method. Method definition should be what? Should be method header plus what? Plus method body. Is it? Or implementation. Okay, and over here, the method implementation is missing. Then you have semicolon. You just have the method prototype. Is it? So that's very new to us here. Is it? And there is another new thing here is what? We also have this abstract keyword. Is it abstract keyword? So what is this? Is it? So in Java, if you have a method that's not implemented and have the abstract keyword, so this is called an abstract method. Abstract method. Okay, abstract method is no implementation. No implementation. Okay, just has a prototype, okay, but with the keyword abstract. Is it? Okay, so this class, this employee class, is what? is an abstract class. Is it because when we define public, is it abstract class employee? Is it? So we define it as abstract class. Is it an abstract class? And then over here we have this abstract method. Is it? And this method we don't implement it. Okay. Then you may ask, why do we need this? Is it? Okay, and for this class, like previously I also mentioned, is it concrete class. And here today we learn abstract class. Is it? So concrete class, you create instance. Is it? So it can instantiate object. Is it? And abstract you cannot instantiate objects. Okay, so that's the major difference between these two classes. Okay, and one can instant, when the other cannot. So my question is regarding new. What is that new keyword used for? So far we learned. The new keyword is related with what? Is associated with what?
Creating, which is instantiating object.
Yeah, so it's used to instantiate objects. Okay, then based on our definition regarding concrete class and abstract class, then for this employee in main, can I then do employee E equals new employee and A, B, 1111111, something like that. Can I do this? Oh, it's also string, so just click.
No.
Yeah, very good. Okay, you cannot do this. Okay, you cannot do new employee. Is it because you cannot instantiate? Okay, you cannot use it to create objects. Okay, so that's called an abstract class. And then what's the use for abstract class? So generally speaking, abstract class, you create an abstract class, is it? And it can be used as super class. So, it can serve as superclass. Superclass, is it? And then this superclass has a lot of common features and common behaviors, is it? And then the subclass can be built based on this superclass so that you don't need to repeat all of the common features and the behaviors, is it? So that's the purpose, okay, for abstract class. Okay, then let's first take a look at the commission employee class. Okay, so here, this commission employee class, is it extends the employee, okay? Employee is abstract class, keep that in mind. Is it? And this, we don't have that keyword abstract, is it? So this is a concrete class. Concrete class, okay. And it has what? Has gross sales and commission rate, is it? Okay, then let's go back and take a look at the employee again. The employee, okay, so here be careful, employee first name, last name, social security, they are defined as private, okay? So the instance variable are defined as private, not as protected, not like what we learned in our last example. And then regarding the commission employee, is it? So commission employee constructor, it first, what does this super mean? What does this super mean? Super here means what?
Constructor.
Yeah, call super class employee constructor. Okay, that's what this part means. And then to try to set its gross sale and commission rate here, is it? And nothing new here, and set commission rate, get commission. So this is similar as what we learned in our last example, is it? And the two string, is there nothing new? Okay, here, you see, you remember the earnings, is it? Earnings in employee in super class. Employee, is it employee? Earnings is a what? Is an abstract method. Abstract method, is it? So no implementation. Implementation, is it? But here, did you see we implement this method? In subclass, is it? In our commission employee, is it? So here we implement this method. This method is not abstract method anymore, okay? It's a concrete method, is it? Okay, not a lot of new things, just okay. This subclass is a concrete class, so you got to implement that abstract method. If you still leave it unimplemented, then this class still an abstract method. Okay, so you need to implement all of the abstract method if subclass want to be a concrete class. Okay, so that's in commission employee. And then base plus employee, is it? And extends what? Commission employee, is it? And then to call commission employees constructor here, is it? And then set its base salary. Okay, set a get a base salary, is it? And call the to string, is it? To string. So let's take a look. Oh, let's go back to take a look at commission employee. Okay, commission employee, so to string. Okay, to string. For this to string here, if you take a look, it first call what? Super data to string. Okay, and then it get its own gross sales and commission employee, is it? So here you see, you can also directly call superclass instance method because that to string is a public. So it's directly accessible, is it? So the question here is, why can I just directly access? You remember yesterday, the example we went over that employee, we directly access first name, last name here, is it? And here, why we can we access? Can we access last name? Can we access that last name? Okay, so how about let's clear this and take a look at employee again. Okay, employee is it abstract class? And its instance variable, first name, last name, social security, and they are defined as private, okay? And then commission employee, is it? And the employee, it has that toString, is that okay? In toString, we use get first, get last, get security. So here you can also directly access first name, last name as a social security. And then in commission employee, is it? Here we call super data toString, is it? So this is employee classes toString, is it? So my question is, can we also just directly call last name here? Access. Can we directly, because this is subclass, is it? And
But it's
yes,
not protected.
yeah, very good. You cannot, okay. You cannot, okay, because it's what? It's private. Okay, not protected. If you set as protected, then in subclass, you can access it, okay? So that's why, because over here you cannot have, that's why over here you need to call superclass public method, is it? This is a public method. That's why you can directly access, okay? If you want to access superclass method, you just call super dot, okay, super dot. Okay, that's regarding this. And the earnings, is it? If you take a look, this earnings, this is a commission employee, is it? And we calculate its earnings. Okay, and then let's go back to base plus. Is it? The base plus, the toString here is called super dot toString. So who the super refers to? Who the super it refers to? This is super. We always see super.
Commission employee.
Yeah, very good. This is commission employee, okay? Be careful, it's not employee. So who is the director superclass, okay? And then here, if we take a look at this earnings method, is it? We override again. So this override who? Whose earnings? The earnings defined in employee. Is it? It has earnings. And then commission employee. It also has earnings. Is it? So now I have base plus employee. That also has earnings. So my question, this earning override whose earnings? So that's represent inheritance relationship, is it? So this, so generally speaking, when we use UML, is it? So use subclass. If you draw the relationship, point to superclass. And this kind of relationship, we call it is a relationship, okay? Okay, so these earnings override whose? The first, the top one, the middle one, the bottom one. Who's it overrides?
Commission employee.
Yeah, so these guys, okay. Oh, for some reason it's, so over this one, okay. So that's the earnings, okay. Okay, so this one we know. And then let's go back to see. We have two other class. Hourly employee. It's also inherit from employee, is it, as wages hours, so not a lot of new super set wage and set hour, get hour, nothing new. Here it deduces it has its own earnings calculations and it's to string, okay, nothing new. And we also have salary employee. It's also inherited from employee, is it? So very similar as the previously defined class, is it? Okay, then let's go back to the driver part. Okay, the driver part. Okay, so this is a client program, is it? The client program. The client program, then let's take a look. So first, we have a salary employee, is it? An object we call new, is John, is it? And hourly employee, Karen, is it? And commission employee, Sue, okay? Base plus commission employee is Bob. So here we have 4 different employee objects created, is it created? So nothing new here, okay? And then what next is for each employee, is it? It called the earnings. So the earnings will be what? Will be from the corresponding earnings method from that class. Okay, be careful. It's not employees. Okay, it's not employees. Okay, so so this just called the corresponding, call the respective classes earnings method. Is it the corresponding one? Okay, so nothing new here. Okay, then here we have define a employee array, is it? And you remember we said employee is abstract class. And why do I cannot use new, is it? Cannot use new. But why here I can use new? Is it wrong? Because abstract, you're not supposed to do new. Why here I do new? Is it legal? Is this legal, legitimate? Is this legitimate?
Yes, it should be.
There should be why?
Just because it looks like it's an array based on the class employee.
Yeah. So this new is for what? This new is for array, okay? It has nothing to do with employee, okay? So be very careful, so don't get confused, okay? Yeah, so that's definitely, it's for array there. Okay, so, okay, then let's see, that, and then we use the array's first element. We assign salary employee to it. Is this legal? Abstract class, suppose it cannot be used to instantiate an object. Why you get an object to it? Is this legal?
Well, it's not instantiation, right?
Yeah, and this means what? Because this,
It just refers to the same object.
Yeah, so this is superclass type. Is it? And this is what? It's subclass object. Is it? So it's legal, it's legitimate if you assign a subclass object to a superclass type of variable. That's completely fine, okay? And here it also shows, is it? Because the array type is employee, is it? Then for each element, is it? You assign it to a different concrete subclass, is it? So this is completely legitimate, is it? Is four different type of concrete subclass objects, is it? And you assign to the corresponding superclass types the element from the array, is it? So this is completely legitimate, okay? Okay, then next, let's see. Over here, have we ever discussed this kind of for loop? I remember we covered this, is it? Because normally when we do loop, we do for integer I from 0, I less than some size, is it? I plus plus. And over here, I do this. Did I ever cover this? This kind of for loop? It's quite normal. I remember we covered, as I mentioned before. Who still remember that?
For each loop?
Yeah,
I
very
think you
good.
did cover it.
Yeah, this is for each loop. Okay, we did cover it. Okay, but be careful, it's not everything you can use for each loop. Okay, this is because the employee is an array. Okay, that's why you can use for each loop. Okay, so for each loop, generally speaking, is you write as for the data type. Okay, follow that is loop variable with colon. Okay, with colon, and then some collection. Later on we will learn, okay, some collection or array. Is there something like that? So then, so this employee will take each one of the elements through the loop, is it? So that's this part. Okay, and then we do print current employee, is it? And here I basically skip call what? Calling what here? Why I can directly do print line here? Because generally speaking, you shouldn't be able to, is it? But why here I can directly do the print line? It's because what? Because it skip calling what? The toString method, okay? The toString method, okay? That's why you can directly call toString method. Okay, so here be careful. The superclass object, it has the toString method. ToString method, is it? And assuming we don't have that toString in superclass object, and then if a class you define doesn't have the toString method, Then if you do this, you will have error. Okay, the program will have error. It won't run correctly. And here you can directly do this is because it's equivalent to you call current employee data to string. Okay, so basically here it's you call current employee dot to string. It's equivalent to you call this. Okay, so here then the question is, we have so many to string, is it? We have object to string, then we have employee to string. Then today we have a number of, then we have commission, and we have salary, and we have what? We have hourly, and over here we have base plus. All of this, is it? And everyone has a to string. So over here, this to string is whose to string?
Of the current object. So
Yes, very good. Okay, it's employees. Employee classes to string. No, is it because that to string not implemented? Is it? So it will be what? This to string is from either commission employee. Is it all from salary, all from hourly, all from base plus? Is it? So the corresponding one depends on who it is associated with. Is it who it is associated with? And this once again shows what in OOP regarding encapsulation or inheritance. So for this, all polymorphism, which one it reflects here?
polymorphism.
Yeah, it reflects polymorphism. Is it? And it also what? The data to string. Is it? It once again also shows what? Shows dynamic binding. Is it because current employee, the type, you say, oh, it's employee, is it? But when you really call the method, it will know which one is going to call. It's dynamic binded, is it? Yeah, so this once again shows the concept of dynamic binding. Okay. And then let's take a further look. Okay. Okay, so nothing new here. We already understand. Then to check if the current employee is from this class. So instance of is used to check class type. Is it? Check if it is come from that class. Is it? If it is, then I'm going to do what? What do we call this? Parentheses. And then following current employee. What is the type of current employee? The type is what? Employee. Is it? And why we need to do this? This is superclass. Is it? So the left side, superclass variable equals right side, subclass objects. This is legitimate. Is it legitimate? And over here, the left side subclass, right side superclass. You cannot do this. It's illegal. We cannot do that. And what do we call this? Anyone knows? This is what? This is called casting. Casting. Okay, you cast it, okay, to subclass because the current employee, when you loop, if it is this instance, is it to that specific object? It is it? So that's why you can cast it, okay, you cast it. Anyway, then over here, is it for this employee, I call its base salary. I reset its base salary. Is it reset its base salary? Okay, and then I output current employees' earnings. So when I call the current employees' earnings, so if I do another one here, so I copy the system data print line, is that print line, that current employee data earnings. So my question is, will this output and this output be the same? Will these two output the same? Will these two output the same? Current employee.
Could you clarify what does casting mean? Casting.
Oh, casting. Casting suppose a lot of time, you see, if you have an integer I as it equals 10, is it? And if you do float j, is it equals I? And this type doesn't match. Is it? Generally, when you do assignment, the right side and the left side, the data type should match with each other. Is it? But integer and floating, you can kind of convert to each other. Is it?
So casting is conversion to an object?
Yeah, kind of, yeah. But non-convert, if over here you have a type, t equals new type, and you say, oh, I call float t, that won't be able to convert. Okay, it's a certain type that convertible, then you can, otherwise you cannot. It's not everything you can do casting, okay? But here the relationship is superclass and the subclass. So that's why here you can do casting, okay? Okay, that's so let's get back to our the earnings. Will this two output exactly same or not? The question is. So it will be what? Different, is it? So earnings changed. Is it? Why is it changed? Because what? Because you reset its base salary. Is it? Even though you say, oh, I call on employee, and this guy and this guy both what? Refer to same memory location. Is it? Same object. Is it? The reference is same. That's why even though you change on the other, it's basically happens on the same object. So that's why that box is changed. It doesn't matter if you name. Is it just kind of that box? Is it the same box? Is it the box? I can call it CS265. Is it? I can also give it a name called data structure. It doesn't matter. They both point to the box. So if you change anything in the box, when you refer to this two, definitely it's change it. Is it? So that's the concept. Okay. Because
So we can
this
have
is shallow copy. Yeah, go ahead.
so we can have two objects which have different class, which like base plus commission and anything else, and they point to the same memory location.
Can you repeat your question again so that I will clarify?
So we can have two objects, like for example, object hourly employee class and base plus commission employee, and those
You
two
have
objects.
two objects. Yeah. Two
Sorry, it's like one object, but they
Oh.
point to one memory location.
One object.
Two different
one box.
references. Yeah.
One object. Okay. This must be like employee. Okay, and this can be like hourly.
And this is legal, right?
Yeah, that's okay between these two. But if you say, oh, this is base. Oh, sorry. Where is it? Where did, okay. If you say this is base, then you cannot, because those two are not the same. Only if it's superclass and subclass, then that's fine. Okay, if you do one base, 1 hourly, you want both are different time, you want both of them point to the same location, that's not achievable. That makes sense? Yeah, but you can.
Thank you.
Yeah, because in this case, E is employee, is it? You set E equals E2, is it? You do that, is it? It's just, this is just a sign, is it just a name, okay? So that is fine, okay. And the last part is pretty simple. In this program, the last part is just to try to see each of the employee class. Is it the output the name? And you will see it's not employee here. So what you will get is each of the subclass's name. Okay, it's not employee. Okay, here what you get the output. Even though here you use that employee array, okay, but because the real object is the subclass type, is it? So that's why it will get the name. Okay, so basically that's all of the information for today.